Welcome to the 7th part of the video. 1, 2, 3, 4, 5, 6, 7. Yep. Sequential counter this time. Okay, sequences are zero terminated. Okay. Read a sequence from in. Write the sum to out.s. Write the length to out.l. Okay. So this is a sequence. This is not a sequence. This is just so happens to be the number, I think, because then this would have a null terminator right here. So sequence 35. The sum of that sequence is simply 35. Okay. And then the length is 1. Then that is the answer of this. 1, 2, 3, 4, 5. 5. Blah, 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 blah. 0 is... Sequences are zero terminated. So the first value is a terminator? Now the first value cannot be terminated, because I will read this. Will I? Yeah, I'll read this. 0. Sequences are zero terminated. Read the sequence A from in. Read a sequence from in. Because the logic here, 0, 0, is this is the first element of the sequence. This is the terminator. In a normal program, we would have something like, in quotations, like maybe like, in like as a string. These can be strings, for example. Yeah, we can think of them as strings, where these two zeros are different. Because what we're doing here is we're basically working with C strings. So in C, strings are terminated with a null character, which is 0 exactly. And so this would be like a string. So this would be maybe the first character. I guess because we're working with high numbers, I guess, yeah, this can be like the decimal representation of a number, for example. I don't know. Usually it's in ASCII it would be a little different, but let's just assume that. But this would be 0. I just want to deal with this edge case. It's annoying. Because my program, what I would do instantly would be like, oh, null terminated, 0 terminated. Okay. Whenever I spot a 0, skip it and move on, and add everything, blah blah blah, move it to the correct places, and move on. 0, 0. Yeah, okay. This would be good enough because I'd reset it. 0 so this is terminated. Then it would get the correct answer. It would be this, because that's that sequence. 3. Then it sees null. It's terminated. Our output so far is 0, so it's 0, 0. Okay, that's fine. It wasn't as complicated as I thought it would be. So we read a sequence 0 terminated, read a sequence from in, write the sum of out to output out.s, write the length to out.l. Okay. So what I'm going to do is I'm going to have a loop, and I'll read up to the accumulator. I don't think my loop starts here, even though it would be nice if it did, but I don't think it does. Because we want to check if it's 0. So we're gonna basically create like a while loop. Should I write this in C first and then convert it into assembly? Nah, I don't think so. I'll just think of the while loop in assembly. So I would have some type of counter, which I can store in back, and my accumulator will store the answer. So back right now is 0, that's fine. I'll say at the start of the loop, no, at the end of the loop, I will, guess I'll move accumulator down, swap, move accumulator right. So this is back. So ACK will be my sum, back will be my length. So that means I think so. I guess I want to reduce the amount of nodes, right? I would be using 6 instead of 4. So let me use 4 nodes instead. Therefore, I'll swap and I'll move back down. I'll move up, down, move up, down, move up, down, move up, right, move left, down. So this would be the sum, this would be the length is received, and it goes down. So this is 1, 2, 3, 4 nodes instead of 6. So that's the end of the loop. Okay, and at the start, I want to check to see if I receive a 0. Okay, what I would do is I would have 35, then I would add my sum, and if it stays the same, that means it has been null terminated. It has been null terminated, yes. Which means, is there a way for me to remember what my previous answer was? Two registers. I can't believe this game has 2 registers. What? So I'm so used to having like at least 4. Like I think x86 has like 4 general purpose registers, and then specialized ones are like another 3, 4 maybe. So 35 plus 0 is 35. Back. I'm gonna have to add back. I'm gonna have to swap each time. Incrementing back. That's, I mean, it sounds bad, but is it that bad? It's like 2 instructions per cycle, per loop, and it's gonna be doing a lot of loops. Yeah, I mean, that's the only reasonable thing I'm thinking of. Then you have, okay, so Let me reference the manual again. No up, label, save, add, negate. To the accumulator. What I could do actually is instead of having back incrementally, instead of having back like does +1 +1 +1 +1 +1 +1 +1, I could utilize the other axe here, because what I'm doing here is I'm just using 2 of these registers, but it's actually not 2 registers, it's 2 registers per node. So why wouldn't I just pass the back down to ACK maybe, and well, it will be passed to ACK, I know it will, but I'll pass it down and I'll have a loop. So my first answer should be my length. Yeah. And I'll loop here. Yeah. Okay. So, okay, how would I do this? I would... Okay, let me remove this. So I take that and I'll say move. So it has the accumulator, right? Then I'm gonna do check if it's equal to 0. If it's equal to 0, jump equal to 0. I'll call it easy. Therefore, that's the end. It's null terminated. And that means I'll jump back to the start of the program. But before I do, I won't increment the length. I will increment... I won't increment anything. I won't give anything either. No, I'll have to give ACK. And I can give 0. And whenever I see a 0 for that. Yeah, okay. So I'll actually swap these two. Move 0 down. I'll use this 0 as a way of telling my looping mechanism here to stop incrementing my length. So what I'm going to do here is this will accept the actual length. So what it's going to do is it's going to have a loop called L. It's going to increment to ACK, and it's going to say, it's going to jump equals Z. Easy, else jump to L. So it's an easy way of incrementing ACK, and then it increments it each time. What I'll be doing is I'll be sending, instead of 0, I'll be sending the 1 each time. So this is the end of the program. So I guess I'll just call it L for loop. And I'll say if it's not equal to Z, then I will. I guess I don't want to, I want to add. Is it good? Is it okay to assume that ACK will be 0 at the start of the program? Because in some assembly languages, you can't do that. I'm just going to assume you can. So what I'm going to do is, I guess I'm going to add up. Is this valid? Jump L. Wait, why would I jump L? Oh, it's the end of the loop. I don't need a jump instruction. It'll go there anyway. So it's adding to the accumulator. So it's adding the sum. And then when the accumulator is 0, which it's not, I guess I'll move. Before the program starts, I'll need it back anyway, I think. I'll say back. I'll say that's that's like probably 2 instructions. I swap, then I say whatever. What if I don't swap? No, I'll swap. Then I say move up to the accumulator. Swap again. Oh, that's awful. No, what if I move up the accumulator? Then I save. Yeah, that's better. Then I save. So let's say 35. Then I add 30. So let's say I add. Then I say, how do I can't compare the two. And because right now, these would still be equivalent because it would add 0. Add up. I need to utilize the registers more. That was my flaw. Move up accumulator. That's fine. It's 35. Then I save it. Should I save it as... I'll only save it as... Okay. I need to think. Yeah. Yes or no? Yeah, I'll do if I receive a 0, then I do that. Else I'll add my... How would I add it? How do I add my back and ack together in a single node? I have 35 in ack. Now I wanna add it to back. So should I go left and then right? That would be using a node, and I don't like using nodes. I'm thinking it would be pretty simple to just go left, increment ack with the value. So I have 35. I give it 35. It does ack plus 35, then it gives it back. But is there another way of doing it? Not so sure. I get ack, which is 35. I'll check if it's 0. If it's not 0, I wanna... yeah, no way. I'll move it. I don't think I check here, do I? My mind is think. 35. It's not 0. Therefore, I will I'll go here, but I will accept 0. But my accumulator is not this accumulator. It's actually coming from the left. Because what I'm going to be doing is I'm going to get 35. I will check if it's not 0. I will move the accumulator left. Is the left down? Is that how it is? Right down? Yeah. Left down. I'll move the accumulator left. Then I'll say add accumulator. Add what? Right to the accumulator. So that's going to be the sum. I will loop in L, jump L. I will add up. Why would I add up ever? Why would I do that? No, I will just move the accumulator left, which will count my sum here. This will count my sum, this will count my length, and it'll move down. Yeah, I mean, it's close to each other. It's close to each other. Yeah, I mean, it's fine. Okay, so I'll move it left. This will count my sum. So here I want to now let this count my length. So I'll say move 1 down. So this will count my length. So it's going to say I've received the accumulator. How do I count it? I can use back to store it. Yeah, I'll use back. I'll say move. Then I want to swap. Then I want to do well, I wouldn't want to swap right here. I want to move, I'm moving 1 down. I want to increment my accumulator, but in order to increment my accumulator, I must make sure that I don't receive a 0. So what I'm gonna do is I might need another node, huh? Probably here somewhere. Okay, how about I focus on one thing at a time. So I take my accumulator. If it's not 0, I will increment it. So I'm gonna add it to the right. And I want to loop and keep adding. So what I want to do is I want to move right to the accumulator. Then I want to do GZ EZ guess not equal to, I'll say, and easy. And I'll move this here. This here. Right. And then once it is 0, I'll move accumulator right. So it takes in 35. 35, that's not equal to 0. It gives it here. It does. This is now 35. Then it says, yeah, but this add will destroy this part. So I guess when I do this, I'll have to swap. I swap before I add. Would that make more sense? So 35 is in here. It's not 0. It's not 0. Therefore, it'll swap. And it will add the... Ooh, the accumulator is now... Yeah, that's an issue. There is no way for me to read back an ACK. Ugh. I mean, I can do the stupid thing of just send the information twice. I mean, I can. So the first information is so that I can... just check if it's 0. Move ACK right. So this is my answer. Not 0. And if it's not 0, then jump. But if it is 0, which means it's been null terminated, my accumulator so far is my answer. Okay. But that will cause a deadlock if 0 and 0 happen. Because it's going to take it. It's going to say it is 0. It's going to go right. But it's going to be like, uh-oh. You're still going to receive an input. Oof. That is awful. I don't know. It makes no sense for the accumulator to check if it's 0 or not. Just add. Add for as many times as you're told to add. That's my logic. Just, for me, it would just make sense to add right, and then, you want to loop add. You're told to add, so you'll add and you'll give the answer back. Yeah, you're told to add, so you'll add right, and you'll give the answer back. So I will accept the answer. And I will swap. Okay, let's run through it again. I take in 35. If it's equal to 0, if it's equal to 0, it'll do that thing. We don't care about that condition just yet. If it's not equal to 0, therefore that means I will give you my 35. You just add it with the accumulator you have so far and give it back. And I will use that as a temporary storage in back. So eventually I will come here and I'll know that it's 0. So my back has my answer. That means I want to swap here, which will have the sum, and I will move accumulator down. I will move this. Okay, what is this part? This moves 0. This is 1. This is for the other thing. So it does that, it swaps. I'll move 1 down. And this will have 1. I will then swap it. I can't swap it. I can't swap it. I can't swap it like that. How about I just say my accumulator is the answer so far. So how about I just say add up to the accumulator. So I receive 1, I'll just add 1. I'll add 1, I'll add 1, I'll add 1. But my condition here is, how do I exit? I'll exit by receiving a 0. So what I'll do is I'll just swap. I'll check, I'll say move accumulator, move up accumulator. I'll say J and E, J, E, Z, E, Z. What is it? Swap. So my back gets swapped with my ACK. I'll check if it's 0. If it is 0, I'll have to swap back and say that my accumulator so far is the length. So therefore it'll give me the answer first, and my swap. Why would this swap? Why was I swapping here? Probably for reasons. So let me just assume accumulator down. So this is my length down. So it'll be length down. I'll swap it. I'll check accumulator. Did I receive a 0? Yes. Swap it. My length goes down. And my accumulator, which is my sum. I mean, this is going to be so wrong, but let's just actually debug it. So I take in 35. 35 is not 0. I will move it left. This will increment it for me, which is just 35 so far. I will swap it. I will move 1 down, which will do this part. It'll check to see if that's equal to 0. It doesn't. That jumps back. Then it'll increment, add up. It'll do add up. Hold on. It'll do add up. So, oof. 1 plus 1. That cannot be here. That cannot be here. That cannot be here. Add 1. Add 1. Add 1. Ooh, okay. So these are like, yeah, okay. So that's happens. So it adds 1. It adds 1, but it adds 1. So this might be 1 over. Here it will be 1 over. So it's 2, but it's actually 1 so far, but whatever. It's going to give me 0. I'm going to check it 0. So 2 is my answer so far, so I'm going to bring it down. Then bring that down. So that's 35. That's interesting. I like that. That looks promising. That looks promising. Please be right. That is very wrong. It's always 2. Okay. Oh, it's because I'm moving. Yes. But I have to check it somehow. Debugging assembly be like, okay. I will move 1 down. It's not 0. Therefore, I will add 1 and I'll save. And I'll swap. I'll add 1. I'll swap. Does it not swap to back? Back. I think I have to swap back. So it's from ACK to back. Checks. Now swap back and add 1 to ACK and jump back. Okay. So it swaps it. It adds 1, then it jumps back. So this is 0. So it swaps back and adds 1 and it gives me 1. Okay. So it swaps and adds 1. Okay. What's my sum so far? 2. Okay, this was also wrong. So that some did I add 1 too many? Seems like I had. Oh, I have to reset it eventually. Right? Yeah, it gets too high. And that's even more wrong. Okay. Hold up. Let's just get the length right. So first, we should focus on one thing at a time. 1. That's it. I swapped backs, and then I have to say I have to reset it. I cannot move ACK to 0, excuse me. Okay, what? Move 0 to ACK. Okay. Blah 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 blah. Now we don't care about ACK. So we start again. 1. Blah 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 blah. 2. Blah 3. 4. 5. Yes, we got the length right so far. That's great. That's great. But we got the sum wrong. But it's clearly because I don't reset accumulator once I'm done. Add right. I'll move it. So yeah. So what I'm gonna do here is I'm gonna say. Now I have to reset it somehow. How will it know to reset? Clearly I'm done with it. So would I somehow null terminate it myself as well? Oh. Move up, move right, accumulator. J easy, easy. Swap back. Blah blah blah. Easy. Accumulator 0. Jump, swap. Jump L. And then I say move 0 to the accumulator. So what's gonna happen is it's gonna take in 35, sub the values, add right. Gonna be stuck adding right forever, that's for sure. How about I save, because we don't really care. Sims 35, add right. Add right. Oh, it's stuck halting. It's idle. That's because it's waiting for an answer. And add right. So okay, wait, this is back. Back will get this. Then it's gonna say if it's 0. It's not. It doesn't really care, so we'll just save. But no, it'll swap. It'll swap back, and we'll say we'll say move ACK. We'll say add right. That means I need to give it twice. Do I give it twice? No, I don't think I can. I have to just use this. But the thing is, I used add 1, whereas I need to add right. I need to add to the accumulator, so it's actually harder. Okay. What I'm gonna do is I'm gonna accept that. I'm gonna say swap. I'm gonna say move. I can't do that. I can't compare the two registers. It's impossible. Okay, what was being underutilized? Let's see, move, add right, move, accumulator right. What was being underutilized? 62. What is? Oh, that's my value so far. So is back being utilized? Well, it seems to be. Whoa, it's being idle for a long time. Okay, I'll have to control C a bit. Oof, what was that again? Down? Oh no, I messed that up now. Okay, it's back. Hold up, I have a bit of tendonitis right now. Okay, it's better. I want to reset the accumulator. I really want to reset the accumulator. I want to reset the accumulator. Once it goes here, I wanted to do this part, but then when I go here, I wanted to do another part. How would I reset it in a nice way? Yeah. Add right. I will do. No, there isn't any other way except for accepting it twice. I don't see another way. Okay, wait. How does that work, though? How does that work? How does the 0, 0 work? Oh. It doesn't reset the accumulator. No. How about I accept it from the right. I check if it's 0. If it's 0, I will go to the bottom node, which will no. If it's 0, I'll just give back. No, how would I do this? Let's say I taken the number 35. I will say if it's 0. Then if it's not 0, I'll go down here, which will increment my accumulator. And I'll put it in here. I'll put that value. And if it's not equal to 0, or sorry, if it is 0, which it is at some point, right? At some point it is. Is it 0 at some point? Please tell me it is. I will never give you 0. Now that's a problem. I have to give you 0 as well, huh? That means I'll do the check JC later. This won't cause problems, will it? Hello? Oh, JZ easy. JEZ easy. Where is the problem? There you go. That stalls. Wow. That stalls, huh? Why? Why does that stall? All I'm doing is... Let me look at the manual, actually. It specifies when deadlocks can occur. Wait, also any, is that useful? Reads... Any is used... This instruction will read the first value that becomes available at any port. When any is used, this solution of an instruction the result... to the board last read or written using any use of okay. Deadlocks. If a node issue a communication command and is never fulfilled by a respondent. Is there a model specific manual? No, no. So this would just give me that. I want to move my accumulator to you as well, even if it's 0. I guess I can do it here. Even though I don't see why. Oh, wait. No, that's not an O moment. Why doesn't this work? It's 0. I'll give you 0. Because I haven't received anything. I'll just say, yeah, it actually doesn't matter. I think it's better to say it this way. If it's 0, I'll say, it'll make more sense. I'll say, give 0 to the left. And then I'll say, loop. I will swap. I will say, are you up? Are you giving me a value right now? If the value is 0, then if the value is 0, I don't need to do the checks here. I'll do the checks there. I'll say move up. I don't even have to swap here. I don't even have to loop. Or do I? I'll loop implicitly. I will move right. And I'll say no. I will receive an input. I will receive an input. I will increment that input. I will increment the input. Increment the accumulator with the accumulator. I'll add up with the accumulator. Well, actually, I think I'm just delaying the issue. I will take an input. I mean, that's delaying the issue, the way I'm thinking about it. But I definitely need one more, I think. I taken my accumulator goes left. I have the accumulator here. I want to check if it's 0. I want to check if it's 0. Because that means it is 0. That means I want to say that my accumulator is bad, basically. I get, It's bad. It's bad. It's bad. It's bad. It's bad. Swap. Swap. Give you. So yeah. Swap back. Give you the accumulator. Reset the accumulator. Sorry, this is if it's 0, right? If it's 0. And if it's not 0, I want to. I'm gonna do this. I'm gonna move the accumulator left twice, and I'll see what's gonna happen with the edge case. Then I'm gonna say add. So checks if it's 0. Then I'll swap back. Then I'm gonna say add the right to the accumulator. Blah blah blah. And then jump loop. Okay. So it's gonna have to do that twice. Jump L. Oh, deadlock. Oh, it wants an input. It wants an input. I basically will say. I'll say. Don't expect to get the input each time. Nah, expect it. You can expect it, that's fine to expect it. Reset the accumulator, please, for the love of God. Oh no, it's expecting something. That's problematic. Deadlock. Okay, wait. I get 35, I swap it. Down. Now I give it 0. Now it'll swap back. It'll give me the accumulator, which at that point I don't care about. I'm pretty sure. And I reset the accumulator. 62 plus 51. Woo, I did it! By the skin of my teeth, if that's the phrase people say. But I did it. 35 instructions, 501 cycles, which is terrible. It's awful. Let's see how slow it runs. Yeah, I mean, it's not pretty. But that's the solution. Wait, and hold up. What's this doing? Nothing. Okay, we can save in instructions. Woo! We can save an instruction. So what's the statistics like? 501 cycles, 34 instructions. Now that's better. I'm just looking and I'm like, doesn't look nice. Like I'm seeing this and I'm thinking, why can't I just remove this part? Move 0 left. Copy this and move it here. And I can. Great. I'll continue editing this. I'll add this. This will add the ones. Let me see. Back. So what's it doing? What's back? Back, yeah, so it reads in, so it has to have a register for reading. The sum so far. That looks a little bit bad. Because these are identical. So why don't I just not expect a value for my accumulator? Why don't I just not expect it here, but expect it here? So for example, I guess I can comment this finally. I don't expect my accumulator, but I will swap. And sorry. And therefore I won't give you the accumulator so far, but I will give you the accumulator here. Okay, that's very much wrong. Why is that wrong? 35, blah, blah. Okay. Swap. Okay, I mean, that's gonna be, obviously, it's gonna be a good answer. 62. For some reason, that's 62. We don't care. Blah, 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 blah. 260, whenever that gets 260, we really care. Okay, that's 260. That's gonna give us 0. Perfect. Now we swap back. We want to give 260. And we do. And apparently we swap back, which we don't need to do. I don't think we need to swap back. Nice. Okay, so we can let's go back. I can save some instructions. I'll make this more obvious. Instead of doing that, I'll say I'll move left down. Then what was it? No, that's wrong. I think it was wait. Okay, wait, continue the segment. Copy this, move it there. This should work anyway. Doesn't. Oh yeah. Because of that order. So instead I can just move it this to make this more obvious. Cool. And I'll say move left down. Cool. And then I can remove this part. Can remove this part. And because the swap is actually unnecessary, because I'm going to be moving to accumulator, this swap seems to be unnecessary, which of course it is. And then that means accumulator, I can actually use back is is being underutilized, which means I can actually use back as my incrementer thing. So what I can do here actually is I'll add 1 to the accumulator, then I'll swap back. Sorry, I'll add 1 to the accumulator, then I'll swap back. And then in the end, back should have, so 1, back is 2. Ooh, I'll have to reset it. So I can do, that'll save me a bunch of instructions. Yeah, that swap is not the prettiest. I want to swap, get my back, increment it by 1, swap it back to save it. Then I want to eventually I want to get to this part where I'm gonna say I want to swap it. Okay, I think it's a bit dangerous to modify all of this. So what I'm actually gonna do is I think it was like this, hopefully. Yeah. What I'm gonna do is I'm gonna copy the program here, and I'm going to basically remove this part and try and make it here, because back is being underutilized. Yeah. Okay, so instead of moving 1 down, I will swap. I will add 1, then I'll swap back. And then at this point, I guess I'll just run the program a little bit. Add 1 and it goes down, yeah. So instead of left down, instead of 0 down, I'll say swap accumulator down. Then I'm gonna say 0 down, 0. Accumulator is the length. So I'll say, okay, well, that's wrong. That's wrong already. Why is that wrong already? Why is that wrong already? Let's have a look. So down is only down here. Oh, you're not receiving any input. Oh, it's no. It's where is it? Accumulator down, swap. I guess I'll just call up. Up 0. Oh, this resets the accumulator, but this won't actually be, this won't do addition. Okay. So my back is going to be my length. Perfect. Then I'm going to give perfect. Okay, good. That reduced the amount of cycles by 3, but a lot less instructions, which is good. Can I clean it up even more? No, I mean, maybe, but I'm utilizing both of these instructions. I receive, I'll add it, all inside of one node. I'll take input, then I'll have that. Yeah, that looks pretty optimized for me. I mean, even though these are idle most of the time, I mean, they have to be because we're doing so many operations, summing, so they can't be all active. But if we could somehow separate some of this into here, we'll have to do... Now we'll have the same amount of cycles because we do have to increment the sum. The sum requires input. I think this is a good enough solution. Yeah, I mean, it's fairly good. Okay, thank you for watching.